Okay, so we're just going to continue reading in the book. So everybody get your books open to page 11. As we get to our last 4 vocab words, we will stop and fill in our cards. Okay, so yesterday we were talking about elements, and the only type of element that we've gotten so far is to metals. Today we're moving on to non-metals and semi-metals. Okay, what does the prefix non mean? Harper? Not. Okay, so we have some that are not metals. What do you think it means if they're semi-metals? Abby?
Partially.
Okay, so what do you think how can something be partially metal? How can something be partially metal? Sadie?
It can be like metal mixed with another material.
Okay, possibly. Harper?
It could be like metal and plastic.
So you're saying the same thing she is, you just gave an example, okay? So it just means that it has some of the characteristics of metals, okay? Like magnetic or the luster of it. So let's go, it'll get to us, or it'll get to the definition in just a second. So follow along as I read on page 11. Elements that do not conduct heat or electricity very well are called non-metals. So we said metals are the ones where the electricity and the heat flows through them. Non-metals do not conduct heat and electricity very well. Okay, and I'm just going to use an example here. It's not that they don't allow it at all. It's they don't allow it to flow through easily. Okay? At home with my oven mitts. Do you guys all know what an oven mitt is? Mm-hmm. I have one oven mitt it's made out of silicone, which is like a rubbery like material. Okay? When I use that oven mitt, it works if I get something out of the oven very quickly. Okay, but if I hold it for very long, it gets really hot on my hands. Okay, so it allows me to hold on to the hot pan because the heat flows through it. It just doesn't flow through it very, very quickly. Okay, so eventually my hands will get really hot and I'll have to put the pan down. So it's not metal because the heat doesn't flow very quickly through it. Does that make sense? So just because it's a non-metal doesn't mean that heat can't still get through it. Does that make sense? Okay. So there are elements, I'm going to read again. Elements that do not conduct heat or electricity very well are called non-metals. Some non-metals are gases. One example is the oxygen you breathe. Other nonmetals, such as carbon, are solid. Semi-metals are elements that are sometimes like metals and sometimes like nonmetals. For example, they may conduct electricity, but only when the light is shining on them. One of the most useful semi-metals is silicone. So like the one I was just talking about. Under that, it says silicone can be obtained from sand. The rod on the right is made of purified silicon. It will be used to make chips for electronic devices such as pocket calculators and computers. Number 4 says, give an example of what other electronic devices might have silicon chips inside of it. So I want you to take a second and think about, because it gave us the example of calculators and computers have it. So in the little chips on the inside, the microchips, think about what other devices might have that in it. I want everybody to try and write something in your book. Everybody try and answer that one. Okay, Jude, what'd you come up with?
Computers.
They told us computers. That was the example they gave us. Abby?
Phone.
Okay, more specific. Like this kind of phone?
No, like a phone that you can play games on.
What do we call those phones?
Well, it could be a Samsung.
A mobile phone or cell phone. Okay, so cell phones, yes. Possibly landline phones, probably. Sadie?
Mobile device may have to do with that chip.
Okay, mobile device is a cell phone. Anybody have something besides a phone?
Your smartboard?
Okay, possibly my smart board, because it is a form of mobile device. I agree. Parker?
A car maybe?
More specific.
Electric car? Tesla.
No. Brady?
An electronic toaster.
Most.
Like one of the screens.
Oh, yeah.
Yes.
Dane?
Microwave or an oven?
Okay, you guys are thinking of things that plug into the wall. They're not.
I don't. Wait,
Cell phone, good. Digital cameras. Which digital cameras? You guys don't even know what those are probably anymore. Yeah, it's. Okay. Yes, iPads is a mobile device. Yep. Okay, so get at least one of those written down. Let's move on. Over on the right side, sulfur is a solid non-metal, Brady. Sulfur is a solid non-metal. It can be found in nature as a mineral. Sulfur is brittle and burns easily. Sulfur compounds are used to make matches. Raise your hand if you can visualize, or I guess it's visualize even though you're smelling it, the smell of a match. That's the smell of sulfur. Okay, so when you light a match, that scent that you smell, that's the smell of the sulfur. Okay, just a match, not a lighter.
Not a fire either.
No, the match. Okay, like when you light a match and then blow it out. Some of you may have not been around a match, but you would know that smell.
Oh, then around lots of.
Okay, number 5. This one, we would have to go back to what we did yesterday. So, what would happen if you tried to break down a sample of sulfur? Okay, and hold on, before we go on, I'm going to remind you, and I want you to write this on the line. So on the top line of number 5, I want you to write, sulfur is an element. So on the top line of number 5, because it just told us that, but we have to know that. On the top line of number 5, I want you to write sulfur is an element. So it says, what would happen if you tried to break down a sample of sulfur? And I'm reminding you that sulfur is an element. So I want you to all to try to come up with an answer to number 5. You don't have to write it down, just try and get one in your head. Who thinks they know what it is? Brady, what do you think? Okay, I want everybody to stop. Go back over to page 10 and read the second paragraph. Go back over to page 10 and read the second paragraph. Start with the world. Read that paragraph. Haley, it cannot be broken down. Why? Because it's an element, and elements are the ingredients of everything else. Okay, so you can't break down elements any further. So under sulfur is an element, right? It cannot be broken down. Wasn't a trick question, you just had to understand the vocabulary. And I don't think we're quite there yet. Okay, I'm going to keep reading under neon. Neon belongs to a group of elements called noble gases. These gases usually do not combine with other elements. Neon is used in neon signs. Now, the problem is, used to when you would see a sign like that, it was called a neon sign because it was like a little glass tube, like the letters were made out of little glass tubes, and the neon was inside of them. The gas neon was inside of the tubes, creating that color. Okay, that was before the technology of like LED lights. Now, a lot of these signs are made out of like LED lights, like the bright lights you see. Some of them are still neon, but they're used to when you'd see a sign like that open sign, it was always neon on the inside of the glass tubes. Now, the technology is changing, and now when you see these signs like at a gas station or a restaurant somewhere, they're not always neon signs anymore. They found other new technologies, other ways to make the same brightness in other ways. Bryce?
What happened if you broke it?
It's not good.
It's probably done to be.
Is it like a glow stick?
No, there's other stuff in glow sticks. That's everybody says that, or someone says that every year. There's other chemicals in glow sticks, and we actually look that up pretty soon. Okay, go ahead and turn the page, page 12. We're going to keep on going. Hey guys, I need you to stay focused. Come on, let's keep going. Page 12. Atoms. Atoms is the smallest part of an element that still has the properties of the element. The smallest part of an element that still has the properties of the element is called an atom. Atoms are too small to be seen with a regular microscope, but special instruments can show how atoms are arranged. The atoms of each element are different from the atoms of other elements. However, the atoms of all the elements have something in common. They are made of the same three types of particles: protons, neutrons, and electrons. Okay, we're going to stop and we're going to fill out our atom card. Brody and Kendall, I'm filling yours out for you. What is an atom? What is an atom? Lori?
The smallest part of an element that still has the properties of the element.
The smallest part of an element that still has the properties of that element. Okay, I'm going to keep reading. So, and this page, atoms, we're going to spend probably 2 days next week. We're going to spend one whole day looking at atoms, and we're going to learn how to draw atoms for different elements. We're going to talk about protons, electrons, and neutrons a lot more. Like I said, our book gives a ton of information very quickly. So we read through the book, kind of skim through it, and then we dive into more details with our foldables and stuff like that, okay? So this page actually has a ton of information for us to learn about, but it just gives us, like, an atom has protons, electrons, and neutrons, and then we dive deeper into that next week once we get through the reading. Okay, so I'm on the third paragraph. The number of protons determines what element an atom will be. For example, an atom of carbon always has 6 protons. No other element has atoms with 6 protons. Carbon atoms usually have 6 neutrons and 6 electrons as well. But some atoms of carbon may have different numbers of electrons and neutrons. As long as an atom has exactly 6 protons, it will be an atom of carbon. Since all substances are made of elements and all elements are made of atoms, all matter around you is made of atoms. The idea that everything is made of small particles is known as the atomic theory. So that is our next vocab word. So find your vocab card that says atomic theory. And you are going to write the idea that everything is made of small particles. And that's all you have to write. The idea that everything is made of small particles. Let me go up to atomic theory. The idea that everything is made of small particles. Okay, going on, I'm going to talk about gold down at the bottom. Gold is a pure element. All gold is made of the same type of atoms. Every atom of gold has exactly 79 protons. The image shows how atoms in a solid are tightly packed. Protons and neutrons cluster at the center of this atom. This cluster is called the nucleus. Electrons move around the nucleus. So even just that, the solid, how it shows that solids are tightly packed, that's a whole nother topic that we're going to discuss. Difference between solids, liquids, and gas and how their particles are arranged. But what's important down here at the bottom is they're saying the center of an atom is called the what? What did they call it? Bryce, put those away. What did they call the center of an atom? Haley? Nucleus. The nucleus. So on page 12, on that picture, this shows kind of a green little circle in the center. I want you to draw an arrow out to the right of that giant piece of gold and write nucleus, N-U-C-L-E-U-S. Okay, so in your book, that green dot in the center with little orange rings around it, I want you to draw an arrow from that center green circle and write nucleus. Okay, because the nucleus is at the center of an atom. What does it say those things around the rings are? Harper? Electrons. Electrons are around on the rings, okay, kind of circling around the nucleus. The nucleus is made up of what two things? Parker?
Protons and neutrons.
Protons and neutrons. So protons and neutrons are in the center, which we call the nucleus, and the electrons are around the nucleus. Okay, and again, we're going to spend like a whole day next week learning how to draw those. So we're going to skip number 7. Brady.
Wasn't the atomic bomb made taking an atom and then swapping it out with
I don't know. Okay. Number 13, page 13, atomic arrangement. Atoms are often connected to other atoms in specific ways. The way atoms are connected affects the properties of an element. For example, when carbon atoms are connected as flat sheets, the carbon is soft and black. This form of carbon is called graphite. What is graphite? You guys all have graphite. Maya? Yeah, what were you going to call it? Lead, okay? It's not lead in your pencil, it's actually graphite in your pencil, but we call it a lead pencil. So graphite is, if you, in your pencils, the stuff that makes markings on your paper is graphite, okay? So that's a soft, it's saying when it's arranged in a flat sheet, it makes a soft material. So as you write, it kind of wears down because it's a soft substance. Dominic.
I got this from my yellow pencil story last year. It's actually not just graphite, it's both graphite and lead.
Yes, because why don't they just put lead in your pencils?
Because it'd be solid metal.
And what other reason?
It'd be heavy.
Lead is heavier, I agree. Okay, moving on. This form of carbon is called graphite. If the same carbon atoms are connected as pyramids, they form diamonds. Unlike graphite, diamonds are transparent and very hard. However, diamonds and graphite are both made of carbon atoms. So carbons arranged one way make the lead in your pencil. Carbon arranged a different way makes diamonds. So do you think the arrangement affects the end result?
Yes.
Yes, it has a huge effect on it. You're either getting a lead or a diamond. Is there a difference?
Definitely.
Yes, there's a huge difference. And it kind of shows you some pictures of that down at the bottom. Go ahead and turn the page. I'm trying to get through just the text today. Yes?
So like if you had this, you could like turn it to diamonds?
No. Not without a lot of chemical changes and reactions and mixtures. Okay, next page, number 14. Page 14. Compounds. Most things around you are compounds. A compound is a type of matter made of two or more elements. Okay, a compound sentence is a sentence made of two or more sentences combined together, right? A compound in science is a type of matter made of two or more elements. So write that on your compound card. A type of matter made of two or more elements. Okay. In a compound, the atoms of these elements are joined together in a particular way. Table salt is an example of a compound. It is made of the elements sodium and chlorine. Okay, so table salt, the salt that you eat at home, that's table salt that you put on your food. That is a combination of sodium and chlorine. Which of those kind of stands out in your head as something that you probably wouldn't want to ingest? Abby?
Chlorine.
Chlorine. Why? Why do you think you shouldn't ingest that? What comes to your head when you think of chlorine?
Like cold water, and it's like.
Yeah, if you would drink chlorine, what would... You could possibly, yes, you're right. It would be a very, very bad situation. Do you think there's a lot of chlorine, a large amount of chlorine in table salt? No. So in small amounts, chlorine is ingestible. In large amounts, it can be fatal, okay? So they're elements, that it is important in amounts, okay? In small doses, we can ingest a lot of these elements. In large amounts, a lot of these elements could be very harmful to us. Max?
That's what she just said.
Okay, let's keep going. I want to get through a few more pages. So it is made of the elements sodium and chlorine. When elements come together to form a compound, The compound is not simply a mixture of elements. It's a new substance. It is different from its ingredients. Okay, so it's saying when I combine, Parker, sodium and chlorine, it's not mixing those two elements together. You are creating a whole new substance. Okay, so I no longer have sodium and chlorine, I have table salt. Okay, what is another compound that you guys are familiar with? I know you're familiar with it. Dane. Water. I want you to write at the bottom of page 14. You have a little bit of space down there, right? Down at the bottom in the margin. I want you to write, water is a compound. At the bottom of page 14. Page 14 at the bottom in the margin, which is under the bottom lines. Write, water is a compound. Put a colon. What two elements are combined to create water? Harper? Hydrogen and oxygen. Okay, that's a compound most people are familiar with. Does anybody know how many atoms of hydrogen and how many atoms of oxygen are needed to create water? You all know it. I just don't think you know it. Finley? Nope, not the same amount. Brant?
1650?
No. Bryce? 2 what?
Of each.
Nope, not 2 of each. Dane?
1 atom of oxygen and 2 atoms of hydrogen.
Okay, why, Dane, is there only what makes you think that there's only 1 atom of oxygen and 2 atoms of hydrogen? Okay, because he knows water is sometimes referred to as H2O. Most of you have heard that, correct? Mm-hmm. So you knew that, but you didn't know what that meant. What that means is water is made up of 2 hydrogen atoms and 1 oxygen atom. Because H is the abbreviation for hydrogen, O is the abbreviation for oxygen. I want us to come up with one more compound that I know you're familiar with. You've heard it, at least you've heard it. Brant? What do we breathe out?
Carbon dioxide.
Carbon dioxide. I want you to write this. Carbon dioxide. What 2 elements do you think that is made of? Bryce? Shh, there's only 1 Bryce in here. I should only be hearing 1 voice right now.
Oxygen and H2O.
What's the other word that you see up here?
Oh, dioxide.
No, that's the oxygen. The dioxide is oxygen. What's the other word?
Carbon.
Carbon. So carbon dioxide is made of carbon and oxygen. CO2 is carbon dioxide. Carbon dioxide is CO2. The C is the abbreviation for carbon. So it's 1 carbon atom and 2 oxygen atoms together to form carbon dioxide. We talked about carbon on the previous page. Okay, that's like the stuff on the end of a match that helps us light it. Hold on, I'm going to keep reading. We're going to get a little bit further. Okay? Oh, so what the last sentence says it is different from its ingredients. So I'm going to go back to water because we're familiar with water. When you're drinking water, you're like, this oxygen tastes really good.
What?
Yes or no? No, because it's no longer oxygen and hydrogen. It's a mixture of the two that create a whole new substance that we call water. Okay? So a compound is no longer its ingredients, it's a whole new substance. Let's go down at the picture. The top picture is chlorine, which we just talked about. It says it is a poisonous gas. It is greenish yellow, and chlorine reacts strongly with sodium. So it's saying it's poisonous, and we just talked about how it's in our table salt. Says sodium is a soft metal. It can be cut with a knife. It reacts strongly with chlorine. Together, it's showing you a mixture of chlorine molecules and sodium molecules, atoms, to create table salt. It is white and solid. It is not poisonous. Chlorine and sodium combine to form ordinary table salt. So, one of the ingredients is extremely poisonous, okay, by itself. But when we mix it with sodium, the end result of table salt lost the property of being poisonous. Okay, so the end result does not share all of the same properties of its two ingredients. Sometimes the color changes from beginning to end. Hold on, hands down. I haven't asked any questions. We're trying to get through the reading real quick. Okay, let's keep going. Page 15. The smallest particle of a compound that still has the properties of that compound is called a molecule. For example, the smallest particle of water is a water molecule. A water molecule only has 3 atoms. But other molecules, like those of sugar, may have many atoms. Changing the number, kind, or position of the atoms in a molecule would result in a molecule of a different substance. For example, a water molecule always has 1 atom of oxygen and 2 atoms of hydrogen. We've already discussed that. Adding an extra oxygen atom would turn a water molecule into a molecule of a different substance. Okay? So molecule is the smallest particle of a compound that still has the properties of that compound. Fill out that last card, and then we will be done for today. Molecule. Fill out your molecule card.